This is Unit 2, Day 7. So we're starting off with inverses of linear functions. So the other day we talked about inverses. You have to memorize that you are going to switch the x and y values. Okay, but now we're getting more into the functions themselves and the equations. So it says, which of the following represents the equation of the inverse? So when you see that word, you do have to know you're switching the x and y. So start with the given equation that they give you, and we're literally going to switch their spots. So it becomes x equals 5y minus 20, and from here you just solve for y. So get y by itself. Okay, so I would add 20 to both sides of that equation. So I get x plus 20 equals 5y. Now I'm going to divide both sides by 5, and I get x plus 20 all over 5 equals y. But what they did is they kind of butterfly divided these. So you end up with 1/5 x plus 4. And that's equal to my y. So that's why that is going to be choice 4. Okay? Example 50. What is the y-intercept of the inverse? Okay, so we have to do what we just did before. So switch your x and your y, and then you're going to solve for y. So I add 9 to the other side. And now remember, guys, to get rid of 3/5, you multiply by the reciprocal. So I'm going to multiply both sides by 5/3. So 5/3 cancels out on the right. And then it becomes 5/3 times x plus 9. And I'm going to do a little bit of distributing there. So that becomes 5/3 x. And when I multiply 5/3 times 9, I get 15. So there's my equation. Okay? So y is equal to 5/3 x plus 15. And this is my b. That's my y-intercept. Okay? Remember, that's your slope right there. Okay, so that is going to be choice 1. Example 51. Which of the following represents the equation of the inverse? Okay, now this one is in point-slope form, so you want to make sure you switch your x and y. So you're going to get x plus 6 equals 4 times y minus 2. And you want to get y by itself. But again, look at all your choices. All of your choices are in point-slope form. So basically, you're going to divide both sides by 4, so that goes away. Okay? So when I divide both sides by 4, I'm getting x plus 6 over 4 equals y minus 2. So just knowing that it's y minus 2, you can get rid of choices 3 and 4. Okay, and that we're down to a 50% chance here. So now what I'm going to do is I'm going to factor out this 1/4 because the whole thing's being divided by 1/4. And here's what I'm left with. Okay, so again, the whole thing was over 4, so I just pulled it out front and made it 1/4. So it's going to be y minus 2 is equal to 1/4 times x plus 6. So be careful, because these look very similar, except for choice 1's positive 1/4 and choice 2 is negative 1/4. So you're going to want the positive 1/4. Okay? Alright, example 52. Which of the following points lies on the graph of the inverse of y minus 8 equals 5 times the quantity x plus 2? Alright, don't forget, with point-slope form, this would be your y value, this would be your x value, but they have opposite signs. And we talked about that on point-slope form day when I did that lesson. Okay, so that means that's really the point. Now remember, it's not positive 2 for the x, it's negative 2 and positive 8 for the y. This is on the graph, so its inverse is going to be just to reverse those. So it becomes 8, negative 2, which is choice 1. Okay, the hard thing about this is a lot of these questions are really easy. You just kind of have to stop and break down and think about the major vocab words here, what inverse means, and just understanding what point slope is. Okay? Example 53. Which of the following linear functions would not, keyword not, have an inverse that is also a function? Explain how you made your choice. Okay? Well, you can memorize that if the original function is not 1-to-1, then the inverse function is not a function. Okay, so if the original function itself is not 1-to-1, then the inverse function is not a function. So if you read this question again, it says, which of the following linear functions would not have an inverse that is also a function? Okay, so basically I just have to go through here and say, which one of these is not 1-to-1? If you remember, if it's 1-to-1, it has to pass the horizontal line test, okay? So if you look at choice 3, which my answer is, the line y equals 2 would look like this. You'd go up 2. Here's the line y equals 2. That definitely fails the horizontal line test. If that fails the horizontal line test, that means it's not 1-to-1, therefore its inverse is not a function. Okay? It's a little bit confusing, so you might have to rewind and replay that. All right, piecewise linear functions. This is what we're ending with here. You guys learned this a little bit algebra year. You just have to be really, really careful. So basically, when you are considering a piecewise function here in example 54, it has a specific formula. What this means when you read this, for all values from -3 all the way to 0, but not including in 0 because it's not equal to, you're going to apply this function. If the x has a value from 0 all the way to 4, you would apply this function. Okay? So for example, it says create a table of values and graph the function. So all I'm going to do is I look at my first x. My x is -3. Well, -3 falls in this domain, so I have to apply -3 into this function. So when I plug a -3 in, I have -3 minus 3, which is going to result in -6. Okay, next one in my table is -2. -2 is still in this domain, so I plug in a -2, I get -5. Okay, you see what we're doing there? And then plug in a -1, I get a -4. Now 0 is very hard. Be careful with 0. Okay, 0 is not included in this function right here in this domain, so I do have to jump down to the second one because it's 0 is less than or equal to. So I have to plug in 1/2 times 0 plus 4 to get that value, and it results in a 4. Okay? These remaining values, 1, 2, 3, 4, all fall in the domain here, so I would have to substitute in a 1, get its answer. Substitute a 2, get its answer, and so forth. So those are going to result in 4.5, 5, 5.5, 6. Okay? State the range of the function using interval notation. Okay, but before I could do that, I have to graph these. Okay, so I'm just going to start plotting the points. So I go -3, -6. Okay, and then these become the points right here. The only thing you have to be very careful with, it's not included. You still graph it, but it has to remain an open circle there. Okay, now you're going to continue and you graph 0, 4. But it is included, so it remains solid. And you plot those points. Oops, I went past 4. Don't go past 4. And there's that. So there's my graph of that piecewise function. Okay, I didn't put the half points in, but they're right there anyway. State the range. Okay, now remember, range means the lowest point all the way to the highest point. But be careful, it's not going to be everything in between because of this gap in the center here, reading it up and down. So I'm going to start at a -6, and -6 is included, and then it comes up to a 3. So here's -6, it comes up to 3, but you cannot include -3. So it becomes from -6 to -3. You include -6, you don't include -3. Okay, this is the union symbol, which really just means or. And then you're going to jump up here. Where am I up here? I'm at 4. How high does it go? It goes to 6. So it's going to go from 4 to 6. They're both included, so they're square brackets. All right, example 55. The function of f of x is graphed below. Write the piecewise linear formula. So now you guys can see there's 3 separate things happening here, okay? There's this graph in green, this graph in yellow, and then this graph in the purple. So there's 3 separate functions. Okay, so you're going to go f of x is equal to, and we have to list that out. That should be a curly bracket there. All right, well, the first one, you just have to come up with the equation of this line. How do I come up with the equation of a line? I need its y equals mx plus b form, but I need the m, the slope, and the b, the y-intercept. So what I'm going to do is I just count how many up I went. So this is going up 9 over 6 for that green line. Up 9 over 6. So if I have a slope of 9/6, I put that in my calculator. A slope of 9/6 really just reduces to 3/2. Okay? Now, you don't have a y-intercept yet. That green line didn't cross over. So if you were to continue that, you'd go up 3 over 2. Okay, we're just temporarily drawing that in here. And then that's going to have a y-intercept, a b of 7. Okay, so I have a b of 7. So what's that equation going to look like? 3/2 x, that's my slope, plus 7, that is my y-intercept b. Okay? Now you have to say, where does the green happen from? Okay? Well, the x values, it's happening from here all the way to here. So you have to give me those values. So it looks like it's happening from -8, okay, this is -8 all the way down here, up to -2. So it's going to be from -8 less than or equal to x less than -2. We'll talk about why it can't be equal to 2. I know it's colored in, okay, but we'll talk about that. All right, the yellow graph is pretty easy. It's just a flat horizontal line. So normally that would just be the equation y equals 4. Now if you can look over here in my formula, I'm not writing y equals, so it just becomes 4. Okay? Where is it 4 from? Well, it's 4 from here all the way to here. Okay? So that's from -2 all the way to +3. So from -2 all the way to +3. Now you have to make the choice. So in the first domain, I didn't include -2 because I included it down here as -2. You cannot include them in both, okay? You can't. So you could technically take away the equal to down here, but then you would need it up there. All right? And now the last one we have to do is the purple line. And the purple line definitely has a negative slope, but you have to come up with its equation by having its slope and its y-intercept. So this one, it's going down, how many squares is that? That's down 6 over 3. Down 6 over 3. Because you went down, it's -6. Okay, so you went down 6 over 3. So a slope of down 6 over 3 is really a slope of -2. What does that mean? I could have went down 2 over 1. Look, there's a point. Down 2 over 1. Look, there's a point. So I have a slope of -2. If I keep reversing this and I go up 2 over 1, up 2 over 1, up 2 over 1, then that's going to have a y-intercept, if I were to continue that, of being up as high as 10. Okay, that's going to have a b of 10. So it's going to be -2x plus 10. Where is it -2x plus 10? Well, it's going to be from 3 all the way to 6. But again, if I didn't include the 3 up here in this domain, then I'm going to include it down here. So I can set that one equal to. And that one, I can make that 6. Okay? All right, moving on to 56. We're almost done here. Consider the piecewise function. So now just pay attention to that this one says x is strictly less than 2. Okay, you still have to do the values for 2, but you would have an open circle there. Okay? This one is all the values greater than 2, but you can also include it because it's equal to 2. Find the x-intercept. So the key word for x-intercepts,